Good morning and welcome to Software's webinar today. In today's webinar, we're going to be talking about working with online DEM data, that is digital elevation model data, in particular a data set from USGS Earth Explorer's website. For those of you here in today's live session with us, please ask questions and engage with us through the Q&A section of the GoToWebinar panel. We usually address all the questions at the end of the webinar. So there's a lot of, believe it or not, free online LiDAR and DEM data sources, and they're available at different levels, including national, state or provincial, and even by district and municipal levels. And interesting enough, consortium groups have developed websites like Open Topography and the US Interagency Elevation Inventory, combining data from a lot of different sources. Okay, but for today's example, we're going to be focusing on how to get data downloaded from the USGS Earth Explorer website and loaded up into our road design software, RoadEng. The overall workflow that we're going to be demonstrating today can be applied with most other online data sources. And in today's agenda, we're going to start by finding and downloading data from the USGS website, opening up RoadEng and importing that data into our terrain module. And during this import, we'll talk about coordinate transformation, especially if your data is in a different unit of measurement, that is metric. And we'll also show a little bit of thinning the data down, as many data sets can be huge. Next, we'll create a digital terrain model. And finally, we'll add some additional context by placing some background orthophotos. Okay, and that's it for me. And Matt, please take away.
All right, thanks for the introduction, Andy. Yeah, and thanks for everyone else attending. Our webinar today is probably going to be on the shorter side, but hopefully it gives everyone in attendance and those of you watching on YouTube afterwards something useful to use. As Andy mentioned, there's a lot of other sources for publicly available elevation data. There's a few mentioned on the slides. Some that I commonly use include Open Topography. This is the user interface for it. It has a good amount of data in the United States, but if you're in New Zealand, it's a great source for that. Other ones that are common or that I often use include the New Brunswick, so I'm based on the east coast of Canada, so provincial databases for province of New Brunswick. Nova Scotia has one as well. Most of these behave similarly. The Quebec data source is in an FTP format, so hopefully it doesn't, maybe it's not available right now. But it's just a conventional FTP website, and in the main directory there's a shapefile. That's pretty common. You'll either have a shapefile or a KMZ on it, and you can open up that and find which tile you'd like to go to. So here we are. Down here there's a shapefile. That's going to give you a directory of which tiles associated with what, and you can go on there and find your LAS data. Other common ones, yeah, this is by no means a comprehensive list, but even if you're in the United States, the USGS website that we're going to use for our example later might not have what you're looking for. The United States Interagency Elevation Inventory is a good site to get a more comprehensive list. In it, you can navigate to your area of interest, drop a identifier, and you get a breakdown of what products are available, and then it also tells you where you can find those data sources. So without further ado, we'll jump into our example. So our example today is this area of interest. It's a make-believe project, but let's just assume it's a subdivision development in northern New Hampshire. So it should be easy to find, and we just want to come off this road and get the topo data for what it is that we're looking at. So my first step is going to be to go to the data source I'd like to use. So well, there, I guess the National Map Viewer is down. So this is the USGS website that I was planning to use for our presentation today, but it was giving me problems when I prepared for this, so I took a video while it was up and running. Just bear with me while I get that going. Dry run, video. So, usually you don't end up with a 404 not found error. So we go to the USGS website, it may take a moment to upload. We zoom into the area of interest. Sometimes this default base map isn't entirely useful, so I often switch my base map to something with a little bit more information on it. Then just if you missed it, I click this box point tool, so that's going to let me delineate the area of interest that I'm looking for. I select the area I'd like, and then I select the type of data that I'd like. So in this, that first section that I selected, this is the elevation products. So this is the actual DEM data, so raster data. The next item that I select is the elevation source data. So this is the actual LAS files, so the raw LiDAR data that's collected when they fly the LiDAR. So we're going to cover both the data sets in this example. So we select what we'd like, we click Find Products, it takes a moment to populate what's available there for the products, and then it's a matter of deciding what you want to download. So here we have the USGS 1 meter DEM data. It's in GeoTIFF format, so there's some formats that won't be entirely useful for you in RoadEng or Train unless you have another software to use. So those would be like a geodatabase file. Here we've got a GeoTIFF. That's perfect. It's what we'd like. One thing worth noting is that it's a fairly large file. So it's a 10 kilometer by 10 kilometer area, and it's 406 megabytes. So really large, a lot of points in it. When we go to use that, we are going to thin our data down. I click download, and then it takes a moment and pops up in the bottom of my screen and does the download. Now this next step that's taking place here is me looking for the LAS files that I'd like. So it gives us the format down here. So we want the LAS files, and there's two tiles that I'm interested in this case. And sometimes figuring out which tile you're interested in, if you have some overlap in there, it's just a matter of downloading and seeing what's there. And I chose to download the LAS files. You can download LAS or LAZ files. And there's other methods you can use to do this download. You can add it to your cart and then download it all out of your cart after. Yeah, it's a publicly available data source. We're not directly affiliated with it, but hopefully it gives those of you in the States that are interested in using USGS data an example, and those of you that are located elsewhere, an applicable example to work with your topo surfaces that you have. So that shows us how to get the information. So let's pretend that it downloaded onto my computer. I've already downloaded it and have it elsewhere. So usually that would come in my downloads folder. I would copy it and paste it into the project directory that I'd like to use. So let's go that, and let's go webinar and USGS. So the LAS files I've placed in the LAS folder. The DEM files I've placed in the DEM folder. That's just entirely personal preference. And let's get going into terrain. So as I mentioned before, that DEM data set is quite large. So I'm going to bring in a feature to thin it based on first. So I have that KMZ that we were originally looking at. It could be any data source, so as long as it's projected in the same coordinate system, which leads me into talking about coordinate systems. So that KMZ data, KML data is probably always going to be lat long. We're not going to work in lat long today. We're going to work in state plane. So we're going to change our projection to United States state plane, and let's go to New Hampshire. There we are. And we want to work in imperial feet just because it's a US example. Click OK, get the transformation, and there's our line. Now, I don't want that to be modeled in our surface. Oops. So I'm just going to change my properties for it before I go too much further and forget to do it. Now I have a feature that I can thin based on, so I'm going to grab my DEM data. So DEM data. With this, it is just a TIFF, so there's no unzipping required. And one of the nice things about DEM data is the projection stays with it, so we won't have to figure out what projection it's in. We are prompt here because it's a TIFF, whether we're looking at DEM data or an image data. So it's elevation data, so we'll select that. And then, as I mentioned, the thinning on import, we're going to take care of that here. So that 10 by 10 kilometer tile has a lot of points in it. So it's 1 meter spacing. We know that just from the title. And we're looking at around 100 million points. So there's a good chance, unless you've got a computer that's really, really awesome, you would struggle to look at all 10 million of those points once you build a surface. We recommend folks try and stay under the 10 million mark, but it's not a hard and fast rule. It'll depend on your actual computing power that you have. So to thin that down, I'm going to base it on a region, and let's select the corridor that we'd like to use. So we've got our feature there, and let's set a width of 1,000 feet. So that's project units, and I'm going to define those here in a moment. So here we're saying that within that corridor, we're not skipping any of the points. And then the default, which is the remaining area, I don't care about that information for this example. If I wanted to have contours over there but didn't really care about the level of detail, I could dumb the data down. So skip, I'll skip 19 points, read in 1. But I don't care about any of that data, so I'm just going to skip it all. The projection tab, since it's TIFF, TIFF file DEM data often carry the projection with them. This one does, so I don't have to worry about saying from projection to the projection that we're working in. It's going to happen automatically. We'll hit OK. That's going to take a moment to be brought in, and while that takes place, we can let it run. Depending on how long it takes me to do this next step, I might just cancel it and open up a prepared file. So in another version of terrain, I'm going to bring in our LAS files. So here, again, I'm going to thin the data down on import. So I'm going to grab that same AOI. I'm going to set my projection. And that's good. I'm going to change that it's not modeled. And the reason for that is just there's a zero elevation associated with the points in this. So if we include that in the model, we'll get tiny little cones going down to zero elevation in our TIM. Next, I want to bring in my LAS files. Oh, and I skipped a step. So when you grab the LAS data, it is going to be zipped. So assume I brought it from my downloads folder over to here. Next, I'm going to extract this. So extract all. And I'll do the same for the other tile. Extract all. And that's all extracted. So let's see what we have in there. So we have the LAS files themselves, and then we get a few extra files, one of those being the metadata. So the LAS files aren't going to carry the projection with them. So this is where I'm going to actually look at the metadata and see what it is we're dealing with. So I'm going to scroll down here, and I know where to look in this case because I've already looked at this. So spatial reference information. This data is in UTM zone 19, and it is metric. All right, so I'm going to use that going forward. Another thing, and this is entirely personal preference, I don't want to have to go insert file, bring one tile in, insert another file, bring another tile in. So I'm going to just drag this out and put it right in my LAS folder. So I did that for, I think, the first one. We'll do the same with that one. And then back to terrain. Here, I'm going to click Insert File, LAS. There's our two LAS files. I'm going to click Open. And here we have a couple things that are slightly different than the DEM data. So the first and probably the most important thing is this point class selection. So with the LAS files, they are the raw LiDAR data, or it is the raw LiDAR data. So when an area has LiDAR collected, you get points for everything. So vegetation, you can have a canopy that intercepts a bunch of the points from getting to the ground. You can have buildings, etc. For us, we're using a earthwork software. So let's assume that we don't care about cutting trees down. We want our digital surface model to just represent the terrain, so DTM. So with that, we're going to select ground. So ground is classification 2. And we're good to go. Now selection, I'm going to do the same thing, base it on a corridor, grab that feature that we've brought in, and let's set it to the same corridor with 1,000 feet. So here, again, I don't care about the extra data, so let's just number skipped all. The projection tab here, since it's an LAS file, it doesn't know inherently what the from projection is. So we are going to say UTM zone 19, and it is in metric units. So we got that from the metadata. And that's getting brought in, and I wonder if our other thing is done. While they both plug away, I'm going to go to this one and we'll jump ahead. So when that DEM data gets brought in, you're initially going to see a screen that looks very similar to this. So one of the settings that I had on insert points was to set the DEM data for the points not to be displayed, but we get this big purple blob right off the start because on import, any new points are going to be selected. So if we zoom in, we can see our DEM points. If I click off to the side, they've become deselected and we can't see them anymore. Now let's just zoom in again and we'll get a feel for what we're looking at. Just using the measure tool, and we've got a distance of 3.6 and 2.9. So that's our raster points. At this point, let's go view. Building our 3D surface. Oh, I guess mine's modeled. If it doesn't, that's probably just the way I saved it. So usually you don't get the surface show up right away, in which case you go to train modeling, generate. You can decide how frequent you generate your contours. I'll go 25 feet and 5 for contour intervals. And we can set a maximum side length for our tin edge length, so the triangle edge length. And I'll talk about that a little bit more when we get into the LIS data. So it's set at a relatively small value of 5 feet. That's being calculated. Back in our LAS example, this is what you look at when that file gets brought in. So here it looks quite a bit different right away. You notice we have big holes in the data, and then if we zoom in where there are points, they are by no means on a regular grid. So the reason for that is we're just looking at the bare Earth data, and this is the raw LiDAR data. So it's not a perfect world. You don't get points every 1 meter, or yeah, they just don't appear on a regular grid. Now that both data sets are pretty good. So the DEM data is 1 meter grid, so it's still fairly tight spacing. But something to be aware of if you're using it to design from is the DEM data is derived data. So if you, let's jump back to our DEM surface. So here, let's select all. Here, there's no holes in the data. That's not to say that there is better coverage from the LiDAR that generated this surface. So if there are big holes, let's see here, they are going to appear, actually let's make this bigger. As large planar surfaces. So it's harder to identify where you have data gaps. The other thing is if you have really high resolution in certain areas, you can dumb down your data. So meter by meter grid, that's often not unbearable. It depends what you're doing. If it's something that you're really detail oriented on, it might be better to stick with the LAS files. But those holes are really easy to identify in the LAS files. So when we generate our surface, so train modeling, generate, and we set a maximum side length of 5 feet, it's going to be pretty obvious where those holes are. Let's go to the same settings. And just be a moment. Actually, and while that creates the surface, we can jump back and forth. So back in our DEM, we kind of talked about the data. We'll just take it a step forward and touch on another feature. So since we're dealing with projected data, it's really easy to combine data sources as long as you know the coordinate systems that you're coming from and going to. And since they represent a real place, we can use that to bring in sources from the web. So I'll use our live maps feature, click import. And there we are. So it's zooming to the area of interest, or where our tile block is. We can choose our source, Bing or Google. And we'll just select the area we'd like to grab, hit save, and we'll download that from the web and bring it in as a background file. And just be a moment while that downloads. We'll save it right here. And then we're presented with this dialog box. Since it's coming from Google Earth, it knows it's in lat long, or Bing, I guess in this case, and going to the projection that we're working in. For options, I don't normally mess around with anything here, except occasionally I'll turn up the image quality. There, we've got a nice background feature here. I think I heard a ding. So there's our LAS files, and if we look at the 3D surface here, we get a bunch of holes. So everywhere where there's a hole, the data is more than, the data points are more than 5 feet apart. It's really easy to work around that, but it's nice to use that as a check to identify where you might want to be hesitant on relying on your topo data if it's in an important area. And to remodel it, I just go calculate triangles and turn this up to a big value. So I think the default one is usually 200. And that'll take a little while to generate the contours. It's not too long.
While that's processing, Matt, do we have a time for to answer a question?
Yep. And this is pretty well the end of what I have. So
oh, okay.
Yeah, it'll just give us a more complete model, and while it calculates away, we can answer questions. Just a sec. Oh, I'm not seeing. Oh, there they are. So one of the questions is, can you thin the data if you do not have a corridor feature to start with? For example, we want to find rough alignment before going out to the field to get our GPS track. So yes, absolutely. There are, if you, I'll come back to this. There are a few options. So when I clicked insert, we can base it up. I'm just going to grab we'll grab the LAS data just because it's smaller. I won't do the redo it or anything, but for the selection options, we can thin the entire data set. So without an area of interest, we can say, I want to reduce the quality of everything and just have kind of a wider spaced out data set to work with. So more coarse, but probably appropriate for some preliminary work. Other options too, because I didn't mention it, so if you don't have a preliminary alignment, but you have a rough area of where you'd like to work, you can also use a polygon instead of a corridor. And that could be anything as well. You could just click in a KMZ and Google Earth and say, I'm going to be roughly in this area, and you can keep your high resolution data in that area and trim it down outside of it. Just while we're on the topic of thinning data, you can also do it after the fact. So if you import your data and decide that I don't really want all of it, say you look down here and you're scared away by the number of points, train modeling, simplify, and then you can simplify the data in a few different ways. So basic grid simplification, we're going to have a grid, and in this case a 10-foot grid, and we can say we want at least one point in that 10-foot grid, but we don't care about anything else, and use that to thin our data down. Yeah. Oh, and another question is, do all LAS files come with metadata? I went pretty quick through that part. How do I find the projection? What units it's in? Not all LAS files include metadata. I think the USGS stuff is pretty good for having it. If you're using private LiDAR data, you may not, in which case oftentimes you'll get a LiDAR report, so the actual report that's completed by those that collected it, in which case it'll include the pertinent information about assumptions and quality and coordinate system that's used. Yeah, and then worst case, you get a LiDAR tile that you have no idea where it came from or what units it's in. You can usually narrow it down pretty quickly. Usually the coordinate systems are common ones like UTM or yeah, another one that might be particular for your individual location. So BC, it's common to use BC Albers, in which case it's just a matter of clicking in the EPSG code. And once it's brought in, I often use this export or import feature just to check where I'm at in the world and if it matches up with where I expect to be. I think it's might be our last question. There's another question regarding if I had an option to downloading the DEM or LAS file, which would I choose? I would absolutely choose the LAS file. The DEM data is often pretty good, but how it's generated can be unknown sometimes. So even when it's creating that 1 by 1 meter grid, it might not be generating the points off of the full LiDAR data set in the background. So it might be dumbed down even more than what you expect. But DEM data is very common to be used, and it ultimately depends on the project requirements. Some of the nice things about DEM data is that it's usually easier to share. All right. I think we're good. Andy, do you have any closing comments?
Oh, no. Thanks, Matt.
I forget something. Just a sec.
Oh, right on.
There's our LiDAR data with the maximum side length increased. So there we're filling in the holes, we're allowing the interpolation in the gaps between those points. You can see that there. Excellent. Thanks, everybody.
Okay, thanks, Matt. Thanks, everyone. See you next time.
Thanks for watching another SoftTree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.